just be going through these units, and I'll be explaining some of these questions and how to answer them. So as I was saying, the first thing that I wanted to discuss was your notations. Who is texting now? Let me just... Okay. The first thing that I wanted to discuss was your notations. Your notations, we only have two. We have your set, then we have the one for your interval. So your set, you can note it by your two curly lines. Then your interval, it can be represented in a variety of ways. You can get your closed brackets, you can get your brackets like this. All these parentheses just mean something. Let's just say here you have something like your a to positive theta. So that means now we're including everything from a up until this positive. Let me just change this to the other value that okay, now we have 5. So now it just basically means that we are going to only consider everything from your a up until 5 and including 5. Right. Okay, and another example that I wanted to use, I was using the one where we had your things like your inequalities. Okay, let's just say you have an example where they've giving you something like your 2x is greater than 4. So basically, the first step would be for you to divide by 2 on both sides. Then your x will be greater than 2. Then if you're going to represent this using a number line, here you're going to have your 0. This is where you're going to have your 2. Then now okay, you're going to go and shade this side. Then from this sign that you have, your x should be greater than 2. Then it means your sign is going to be going that side. But now let's just say we had an instance where now we have our 2x is greater than or equals to 4. Then now we'll know our x will be greater than or equals to 4. So now if we're going to be drawing a number line for that one, it now means we're going to be having still the same thing, 2, but now our 2 is going to be shaded because now our 2 is also included. So now it means you're going to be having 2 and all the answers going to your positive infinite. So how you go about writing your answer for the first one is that now since your circle is opened, it means now you're going to be having your answer from 2 to positive infinite. But for the second one, since you have an highlighted dot, it means now we're going to be including everything from 2 up to positive infinite. See? So it's just a matter of knowing where to use your parentheses, which these that are given. So normally if you have something like your greater than or equals to, or your less than or equals to, then you're going to be having this bracket that looks like this. Basically they're just saying they're including that point up to whatever side they would be working on. But you'll just get the hang of it as soon as we try to go through some of the examples. So yeah, don't stress about that one. Those are just some of the basics about your intervals. Okay, we have to do your intervals. After the intervals, it's your functions. Okay, after the functions, let me see. Okay, yeah, now we're going to be doing the functions, but the most important one that, like, I know is going to be repeated a lot. These are going to be your power functions. Let me just adjust this chair. So you're going to be getting a lot of power functions, and it's also important for you to note your your parent function in order to be able to draw your graphs. So let's just say now what do we have. So as I said, let me just write this side that we're going to be doing the power functions. The power functions, number one, we will look at where you have your even numbers and the ones where you have your odd numbers. You see, because most of your functions that you're going to be doing, it's either you're going to be doing your functions that like are in the form of your parabola or in your form of your cubic. So from your grade 11 and your grade 12 experience, you've done a lot of examples on parabola and your cubic. So yeah, you're just going to be refreshing and keeping those at the back of your head as your parent function. So the first example with the parabolas, you're going to get something that looks like this, that they tell you you're gonna have a function where they've given you your y it's equals to your x to the exponent n. Then your n can be your even numbers. Then your n, which is this one, it can be any even numbers. It means it can be your 2, your 4, your 6, your 8, your 6, and so on and so on. So knowing from your grade or your high school experience, you already know that if they tell you to draw your graph of your y is equals to your x, this thing is off, y is equals to x to the exponent squared, then you can simply know that okay, this one is going to be a parabola, and since it's a positive one, it's just going to be a smiling graph that looks like this. And you know, once it's going to be negative this side, it just means now it's just going to be flipped. You see, so that's that. So now it means if you are going to be asked to draw a graph of your y is equals to your 4, your y is equals to x to the exponent 4, and so on, you already know the shape, because you know all those are just like your even numbers. So the only important thing that is changing, it's your n. And also, as I said, you have to note that okay, this is just going to be changing with these values. So you check, is it even or odd? So you'll know the odd ones are going to be falling under your cubics, then the even ones are going to be falling under your parabolas. You see? So with this one, let me just like finish the one I was explaining. Then with this one, if you have one like this, the only questions that you're going to be getting, okay, your first one would be to draw your y is equals to your x squared, as like I've indicated. Then the second one is for you to determine your domain. You see, so remember, here we have our x's, here we have our y values. So with our domain, remember that here we're only looking at our x values. So with our domain, you can see that this graph, it starts somewhere in the negatives. Yeah, somewhere in the negatives, and this side it ends up somewhere in your positives. So you can just simply go and say your domain, which is going to be your x values that you're going to be, because now it means now we have some x values this side that's unknown, and also x values this side that's unknown. Hence, that's why I'm just saying it's going to be minus infinity to positive infinity. But should it be a point that like the x values are given, then now we're going to know that it's going to be from this negative to this positive. But in this instance, we're just going to say it's minus infinity to positive infinity. You see? Then now we go and check for your y values. Your y values are the ones that like are along these lines. So with your y values, what can you note? You can note that your y's are only starting from 0 going up. Hence, you can say you have your 0, which is also included up to your positive infinity. See, because now you're going to be having your y values that like are only going up until that side with the graph. You see, or you can represent it in the form where they tell you this is the one where they tell you that like you have to do it in interval. This would definitely be the one that you do in your intervals. Then if they ask you to do your set, you will see something like your y is such that your y is greater than or equals to 0. Then you include those curly lines. Then that will be okay. Let me just do it. Reply this person. I think I forgot someone with the link. Okay, yeah, that will be your range. So this one was our range, which is basically your y values. So your domain, you check where your x values are starting from. Then also your range, you check where your y values are starting from. Then okay, we're done with the domains and the range. Let me just erase this. Let me erase everything, then I'll just like throw it again. Okay, as I said, we're going to have this one where they say your y is equals to your x to the exponent 2. Then this is the parabola graph that you're going to be having, which this one, it's always going to be your parent function. So should they ask you to draw your graph of your y is equals to your x to the exponent 4, 6, 8, 10, so yeah, you can just like note at the back of it that all those are just even numbers. It's just that like the graph will only widen on this side as like you increase those values. That's the only difference that you're going to be getting, but the shape is just going to be the same. Then if it's negative, the graph is just going to be flipping on this on this side. Okay, so if you have something like your reflections, remember this is how you're going to at least maybe do your graphs much quicker. So remember, the first example that like I used was this one. So let's just say now you have your scenario 2 where they tell you that your y is equals to your x to the exponent n, and your n is equals to your -2, your -4, your -6, and so on. Still, we're still considering our even numbers, you see. So if it's like that, so it means now basically what you're doing, it's your reflections. Remember the one for this one, it's like this. Then we said it's gonna be like this. So if you're going to be doing your reflections in this graph, you're just going to be creating mirrors, or you're creating your mirrors, or you're cutting or forming your X on either side of the graph. It means now if you're going to mirror this, you're going to be having something that looks like this. On this side, it's going to be looking like that. See, so now it means your graph for this one is going to be something that looks like this. Yo, I'm so bad in drawing. So yeah, this would be for this case that you see here. Still here, we just like still using our parabola. Hence you can see this is just like two axes that like are crossing one another. That's one way I like to visualize it. You'll just like see it also with the other examples. Then what else are they gonna ask? Here they're just gonna ask you, okay, you're supposed to draw. Then after drawing, you'll be required to do your domain and your range. So you'll see this value or your graph is just like going as if like it's moving to this line, it's approaching your x values, but like it will never touch the x value. So with this one, you can just say your domain. Okay, we're just going to be doing it in set form. Remember your set form, you're going to be having those the Cayley lines in your set notation. Your x is such that your x should not be equals to 0. Hence I was saying your lines are going to be moving like this, but they will never touch your 0. Then and now you go and check for your y values. Your y values, we're going to check what's happening on your y lines. On your y lines, you can see y is just going to be greater than 0. It means now we're going to be considering this part going up. So now you're going to say your y is such that your y is greater than 0. Then if you were required to write this in your set notation, not set notation, but the other one, the interval. So now it means you're going to be having something that's starting from 0, which is this side, going up to your positive in infinite. You see? So is there anything that they could ask on the parabolas? The parabolas, nah, it's only just going to be this 2. Then now we're going to be moving to the examples where they've given you something like a cubic. So here we haven't even started with WTW yet. We're just like doing the basics. Just doing the basics. So now we're going to be going to your cubics. So your cubics, you just still remember them from your grade 12, that you're going to be getting a graph that looks something like that. So those ones would normally be your cubic graphs. And how do you note your cubic graphs? Your cubic graphs, you know them by your one. These are odd numbers, your 1, 3, 5, 7, 9, and so on. You see? So now let's just say you have an instance where they've given you something like your y is equals to your x to the exponent n. Then your n now, it's your 1, 3, 5, 7, 9, and so on. So then now you're gonna go and say, okay, how is my graph looking like? So the graph would look something like this, as I've indicated. Then okay, if it's like this, remember also, if you can't draw this graph, the one way that like I suggest is for you to use a table format. So you know, okay, if they've given you something like your cubic or your x to the exponent 5, and like you've actually forgot how this graph looks like, you can just like create a range for yourself that, okay, if I'm going to be working strictly from -3 to 3, let me just quickly go and create this graph and see how is it gonna look like. Then you know you're going to have your -3, your -2, your -1, your 0, 1, 2, 3. Then it's going to be like this. Then you remember you have your x to the exponent 5. Where you have your x, you input these values, then you get your corresponding y values. Then after getting these values that you see on this side, you should be able to draw a graph that's similar like this. But this now helps you to know, okay, if I'm having something like my x to the exponent 7, then you can already say that, okay, this 7 here, it's an odd number, so obviously I'm going to be having a shape that's going to be looking like this. But if I have something like my x to the exponent 6, this is an even number. It means now I've gone back to your parabolas, which is going to be something that looks like this. Hence, these your main parent functions that you should always keep in your head. Then okay, let's continue with this one. We were still here. Then now we check again that, okay, what do you have on your x values as your domain? Remember your domains, this is where you have your x values. You can see that we have something here on the negative, then also have something this side on the positive. This is where you have your x values, this is where you have your y values. Then how do you read that? You can see we have these unknown values that's somewhere there, and this unknown positive value that's somewhere up there. So we're just gonna say for this, for your x values, we have -infinity, then at the top we have positive infinity. And as I've said before, should it be that like it's a case where you're provided your numbers, let's just say in this case here it was 3 and this it was -3, it will now mean your domain would be between -3 to 3. You see, so that's that. And also now we're going to check our y values. So now we're going to be concentrating on this line here. That okay, what are we having on our y values? We're still having the very same line where we can just say we have -infinity to positive infinity. Then now the last step that you have to consider is your reflections. Let me just do this. if I'm going to be having the reflections, remember how I do my reflections? I just draw sort of like your X on your both sides. I just like have my first X this side, then I'm going to be having my second X this side. So this means if I'm going to be getting something like my y is equals to my x to the exponent n, it now means my n it's going to be negative. I'm gonna have something like my -1, my -3, my -5, my -7. So how is that graph going to look like? It's going to look like that one that like I've drawn. It's gonna be something like this, also something like that. You see? So now with this one, you know, if you're going to write your domain in your set notation, you'll say you have your x is such that your x should not be equals to 0. Then your range, you will say you have your y is such that your y should not be equals to 0, and you are done. You're done with that one. So overall, you've only dealt with two types of graphs, but like you've broken them into two. We had our x to the exponent n, where we had even numbers like your 2, 4, 6. Then this side we had the reflection, your x to the exponent n. Then we had the -2, the -4. This side we had our cubic graph, where we had our n is equals to your 3, 1, 3, 5. Then this side we had its reflection, where we had our x to the exponent n. Then we had the -1, the -3, and so on and so on. So the last, is it the last one? There is still one where there's still one that you have to know. There's still one that you have to know, Kunje. Okay, we've done cubic, then we've only done, okay, we've done cubic and its reflection, then we've done parabola and its a reflection. So now, okay, let's just say, the last one that like you have to know, it's one where you have your y is equals to your x to the exponent n, but now your n it's okay, the other cases I think I've explained them. This is when you have something like your 1 over n. So now instead of n we have 1 over n. Then I will say, okay, our n would be your positive numbers, which is also your even numbers, like your 2, 4, 6, and so on and so on. So one example will be a case where we have y is equals to x to the exponent 1 over 2. And also, you know, this can be further written as your y is equals to your square root of x. Because like I also remember this was also something that was in your class test. I'm not sure if it was the last class test or what, but like, yeah, it was there on your class test. So simply how this graph looks like, just gonna have something that looks like this. You see? So if each and every case you get something like your x to the exponent 1 over 2, 4, 6, what controls you now is just like these even numbers that you're going to be getting. Instead of 2, they can use 4, 6, 8, 10. All the graph is just going to be looking like this. So now you have to know that, okay, you can get something like your y is equals to your x to the exponent 1 over 2, something like your y is equals to your square root of x. All these things, they're just like same things. So one another way that they could ask you is to ask you to draw a graph that's like let's just see, maybe they've given you something like y, so y is equals to, then they give you something like your 4 root of x. Then you know this is going to be your y is equals to your x, the exponent 1 over 4. And what's this for? That you see this 4, it's an even number. It means now the shape of this graph is going to be looking like this, you see. So because like I've seen also there are questions where they say without actually having to calculate the values, which is that method that like I use, just draw how the graph would look like, meaning they just like they're interested in you drawing the parent function, you see. So yeah, these are just like small details that like you have to remember when you're dealing with this sort of graphs. Then these were the ones for even numbers. So for the ones where you're going to be having your order numbers, let's just say you have something that looks like your y is equals to your x, the exponent 1 over n, but now your n is equals to your 1, 3, 5, 7. It means one example we can say we have y is equals to your x, the exponent 1 over 3. Then we're interested to know how would that graph look like. So basically for this one, the graph would look something, yeah, it's something like this, you see. So yeah, those are the, I think it's like six if not 6 graphs that like you have to know, or six situations. Then now, yeah, we're just going to be starting with doing WTW and going through the examples and explaining through the things, and also reminding you guys of like the things that like we were explaining now until you get the hang of it. Why is it not going up? Okay, let's just still use this page. Then as I said, the only functions that like we have your linear functions, then we have your exponential functions, then we're gonna have the logarithmic, the power functions. So mainly all those examples that you're seeing, those were the power functions. You will see in most of your examples you're going to be getting examples that like are around the power functions. Then when we get to new functions from old function, your composite, you also see how we try to differentiate between all these functions that like you're going to be having. Then let me just quickly check in the book. Did I include these things in the phone? Let me check here. No, I didn't, but like I'll just like write them down or note them this site. I think if I'm zooming like this, it's far much better. Then yeah, just try to find a way how I can add this now. Let me just quickly look them up here. Did I send them to myself? I'm not sure. I just hope I did. Yeah, just a moment. I'm looking for those ones. Okay, I'll just leave them. I'll note them down and also add them for tomorrow's lesson. For tomorrow, I'll just do the ones that I've already included in the session. Let me just write it on the side. Okay, yeah, we can continue, but so far, okay, these ones are there. Yes, let me just remove one. Okay, yeah, let's just start with some nice examples that we have this side, then we'll get back to that one. So the ones for the functions, I think it's best if we start with these ones, the one unit 1.3, because I know these ones are far more challenging. Then we'll end with the ones that not that much challenging. So let me just try to zoom in. Then yeah, you can either write these ones down as I'm busy writing them, or I'll just you'll just wait for me to send you a picture of the questions after the class. So we have something like your 1.3, and as I said, your example 1, 2, 3, those ones are easy. We'll just do them when we're done. I just want to explain this one where I know most they get it wrong. So we have something that's this. They're saying, example 1, consider the functions below. You have actually given two tables. So these sort of examples are the examples that you're going to be getting. It's either on your MCQ perhaps like your 2 marks questions that like you're going to get. Sometimes they just like to give them in your section B if it was something like your semester test 1. So with these ones, your new functions from your old functions, we're basically working from the internal function going outside. So what do I mean? I mean, now we have a situation. Why is this thing? Okay, sorry about that. We have a situation where they've said we are having something like your f of g of o. So with this ones, mainly what we work with the order is that like we always try to work from the in going out. So if I was to write something like this one, so what it means is that like, okay, you in the internal side we have your g of x, then on the external side we have something like your f of x. But now they just like tried to represent them using your tables that like you're given this side. And also one thing to note, you have your f of x this side and you have your g of x at this side. So remember, in this table you have your x and your y values. But now what do you have? You have the g of x and your f of x that side. So please quickly go and try to attempt the questions so that like at least you try to understand what I'm referring to. So with the first one, they said we have to calculate your f of g of 0. So the first step for you to do, you go and check the internal one. We said, okay, our internal function is our g of x. It's our g of x, but now they want what? They want your g of 0. So you will go and say, okay, I have my g of 0. Then where is the table for g? The table for your g's as this one, hence you can see the g this side, then you can see the 0 that side. Then what's the corresponding value that like it's giving you? You can see that like when you have your g of 2, your g of 0, you have an answer of 2, which is going to be this one. So now you got it 2 from the internal function. So it means now we're going to be replacing this one with 2. So now we can say instead of having that, now we're going to be having f of 2. Then you go again that, okay, what's my f of 2? With your f, you know this is the table that you're going to be using. Then you go again and check what's my f of 2 this side. You have your 2 this side and it's giving you a value at the bottom that it's at 6. That is 6. Then you're going to be getting your 6. Then you can just conclude that you can make your conclusion that your f of g of 0 x equals to 6. So remember the first step that like I did, you go and look for the one or the function that's internally. So this is the one that's internal, then this is the one that is external. You have your internal function and your external function. This is the same as having your f of g of x, but now the only thing that we're only changing as your x values. So we said we had the G of 0. We started with the G of 0 and said, okay, we go to the G table, which is the one on the right. Then we go and check what is our G of 0. Our G of 0 is here, reading the X values. Remember, these ones that you see inside, these are the X values. What we're interested in is this corresponding Y values that you're getting in all these table. So we went there and checked what is our G of 0, or our G of our G of 0. Then we got the 2. We've written the 2 down. So it now means on our internal side we only have 2. Then externally we still have f of something. Then we replaced the internal function with 2. This is the step that we did. Then we went and checked what is our f of 2. Then this side, you can see on your left hand side you have the f table, as you can note here. Then we said the f of 2, you get your 6. Then I think I've explained that enough. Now we're going to go to the second example. Why is it doing this? We're gonna go to the second example. You can also try them, it's like we're busy moving. We have our G of f of 0. Then now you know that, okay, we're going to be starting with your internal function. Your internal function is your f of x. Then you can see we have a f of x table this side and your G of x. So it means now we have to check what our f of 0, since it's internally. We go to the proper table. That, okay, the proper table would be the one that you are having on your left. That, okay, when I have my f of 0, or when my x is 0, what corresponding value do I have? You get your 10 this side. So you will say your f of 0 is 10. So it now means we can replace this one with 10 since we've got it. So what we are interested in now is our G of 10. Then you go to this table now, the one for the G's, that, okay, when I have my x value as 10, what do I have as my y value? Then you can see that your y value that you're going to be getting is your 15. So this would be your final answer. Then we go to the last example where they've given you your G such that you have a G of 0. Then, as we've said, we always start internally, going outside. Start with the internal function, then we go to the external function. And we'll say we have our G of 0. What's the answer for G of 0? G of 0 gives you 2. So it means now we have 2. Then remember, this is the one that's internally. We're just going to replace this one that, okay, we've already found a 2, we put a 2. So now it means now you have to find your G of 2. You're still using the same table, so don't be confused. So now you move this side, that, okay, you find your G of 2. Then the final answer is going to be your 3. Then, yeah, I think we've done all the examples for that one. Then we're going to move to example 2. Example 2 is that you're going to get it in 3 ways. You see, like this, like in unit 1.3, like they've tried to at least include 3 examples. So should these examples be in the exam, you're going to get in either one of these ways. So please ensure that, like, you understand all the ways. So example 2, they said you have something like, okay, let's say they say let f of x is equals to your x to the exponent 4 and g of x is equals to your 3 to the exponent x. So they say write down the functions f of g of x and g of f of x. So from these ones you can see they've given you this to find and this to find. So the first one, which is this one, you can see internally what do we have? We have our g of x. So let me just like write it down. They said we should find our f of g of x, you see. So now what does this mean? It means this one is just going to be the one that is going to go inside the other one. So it means now your g of x, this is the one that's on the inside, then this one is going to be the one that is going to be on the outside. Your g of x is basically going to be the one function that's going into, or that's going inside the other one. And what functions do we have this side? We have the first function where they said our f of x, which is the outer one in this case, it's your x to the exponent 4, and they said this side our g of x is equals to your 3 to the exponent x. But now what are they saying? They're saying this g of x has to be inside your f of x. So with this one, just ensure you listen carefully. You only go and put the other function where you see your x values. Where do you see your x values? You can see that you have your x value here. So where you see your x value, you're gonna go and put this one that goes in. So now what does this mean? It means now you're going to be having a final answer for this one where they say you have f of g of x. You're going to be having this x. Remember where I said where you are having the x in red, this is where you're going to be substituting g of x. It means now you're going to be having that 3 of x, which is your g of x, the one that's going to be going in. Then outside we're going to be having this 4, which is already there. So basically what I'm doing, I'm just separating this. So where I'm seeing my x, I go and put this one, you see. So basically I didn't change anything. If you can look at this one and the one at the top, still have the same thing. The only difference is that like from this one I just took it and I placed the g of x inside only where I'm seeing my x. So this would be the first answer for the first one. So it means now the final answer is going to be your 3 to the exponent 4x, because you're just multiplying those at the top. So they say write down the function f of g of x and g of f of x. So now the tables have turned. They say they want your g of f of x. So outside what do we have? We have our g. Our g is this one, which is our 3 to the exponent x. And you remember we are considering the outside function, which is our g of x, which is equals to 3 to the exponent x. And in that function where we see x value, this is where we're going to be putting that one function that's going to be inside the one that's outside, which is your g of x. You see? So we have g of x, which is going to be on the outside. Then it means now your f of x is the one that's going on the inside. So this is the one that's going on the inside. This is the one that's already on the outside. So what do you have? You have your 3 to the exponent x, but you know that you're supposed to be placing your other function where you see your x value. So remember, this is your g. Then now it means you're going to be having your 3. Okay, what are you gonna have? Okay, your f of x is your x to the exponent 4. So now it means you have your x to the exponent for this side. See? So now it means your final answer is going to be what? Your 3 to the exponent x to the power 4. So that would be the one for the second one. And yeah, before I continue, do you guys have any questions on this ones? It's still sorted up to so far. Because now we're just going to be doing example 3 and example 4, which is just going to get tricky. But if you guys are still with me on this one, then we can continue. Let me just erase that. Then if you have a question, just okay, we have done with example 2. So now we're gonna go to example 3. So with example 3, these are normally the ones that they also test like in your test. And as I say, the quickest way to know if you're doing the right things is to name your functions as you're busy taking them out. Remember, when you get something like your composite function, like your example, you have something that looks like this, which is this one that they've asked, and this one. These ones you can, or these two, you can see that this it's made up of how many functions? It's 2 functions. You have g of x that's on the inside and f of x that's on the inside. This one is also made up of 2 functions. You have f of x that's on the inside and g of x that's on the outside. But yeah, you'll just see that it gets trickier and trickier as these examples advances. So we have the first example where they say you have h of 1x, then they've given you your 1 minus x, then you have your root of x. So now basically what they're telling you to write down the function your f of x and also your g of x. So the order is that if you've seen it that they've written in this order that your f of x and your g of x, always assume that the last one that they've written this side, this will be the one that's going to be on the internal side, then this one is going to be the one on the external. So this one is going to be the one on the internal, then this one is going to be the one on the outside. You see? So if we quickly go and review our first example, we can see that we have square root of 1 minus x. So also one rule that I like to use, each and every time you've taken out that function from the other one, you can also try to at least maybe put an x where there was that function that like you've already taken out, because like in this one you can see that okay, if I'm about to take a function, what function can I take? You can take this function, which is your 1 minus x, and you'll say okay, the one that's going to be internal, it's my 1 minus x. And the second question that you have to ask yourself that okay, if I've taken this as a function, what type of a function is this one? Then you'll agree with me that this one is going to be a linear function. You see, so I also said once you've removed that function, make sure that like when you're doing this, you don't get too linear. If you're getting too linear or too power function, it means now you are making a mistake. You're actually supposed to be getting your different functions when you're doing this type of example. So now, as I said, each and every time you remove that function where it was, you just like replace it with x. So now you can see what are you left with. You're basically left with your square root of x. Then this one, you know that okay, it's going to be somewhere here, which is going to be the external one or your outside one. And you've also done a graph that represents that is going to be a graph that looks like this. And we've also said this is the same as having your y is equals to your x to the exponent 1 over 2. So definitely you know that now this would be a power function. You see, so those are the steps that like you have to follow when you're solving this type of questions. You start on the internal side, then after starting on the internal side, you write down the function that you have. Okay, let me do this. You write down the function that you have, which is your 1 minus x. Then you ask yourself, what type of function is this one? Then you write it on the side that okay, it's a linear. Okay, since now I've removed one function, what am I left with? You're actually going to be left with square root of x. As I said, once you've removed this one, you just like where it was, you can just like replace it with an x. So now you're left with a square root of x. Then you know your square root of x is going to be the outside function. Then you ask yourself, what's your square root of x? Then you know your square root of x, it's your power function. So let's continue with the other example. The other example, they have your h of 2x, then you have your sine cube x. You see, so this one you can also just like rearrange it and write it in the form that you have your sine x, then you can say this one is cubed. You see, so they still require the same step that you have to write your f of x and your g of x, which is going to be your internal function and your external function. Then you go and write that okay, you have your f of x, which is the external, then you have your g of x, which is going to be internal. So I'm sure by now you guys are just starting to see how this example goes. That now what do you have? You have this sine of x, which is on the inside. Remember this, I said this is your internal, then this one is going to be external or your xl. The one that you have on your inside, you have your sine of x. And I said once you remove that one, replace it with the x. So now it means you have your x to the exponent 3, which is basically going to be the one that's only left, which is going to be the external one. So now that like you've written this, you ask yourself that okay, am I having two different functions or one? You're actually having two, because this one, your sine of x, this one falls under your logarithmic then this other one falls under your power. Remember the rules I said, you're not supposed to be getting a power and power. It always has to be 2 or 3 different functions. So if you see that like you're getting at least maybe same functions under one problem, you could be making a mistake. So quick way is that, like, try to check that, okay, am I having something that's different, or am I still having something that's still the same? So let's see, check the other one. We've done that one. Then we have cos of x, cos inside, we have, okay, the last one, we have, what's the thing, h of 3. We have h of 3 x, we have cos of x to the exponent. Fine. So this one, I just think it's pretty straightforward. We have f of x, which is your external function. Then we have our g of x, which is going to be the internal function. So with this one, without wasting time, just gonna see that, okay, we have this one that's on the internal side. We have x to the exponent 5. Then after removing this, what are we left with? We're only left with cos of x. As I said, each and every time you remove that one, you can just like replace it with an x. So now it means here we're going to be left with your cos of x. Then to which family does this one belongs to? Then you know this, it's your logarithmic. Then this one, it's your power. You see, it's your power. Then you know which ones exactly, the cubics. Then let's just check. We've done all the examples under example 3. Then now let's just make it a little bit harder with the other example, the continuing example at the top. So now we're going to be getting something that looks like this. Example 4. Example 4, they say write down functions f of x. Sorry about that. They say write the function f of x, g of x, and h of x. You see, now how many functions are you supposed to have? You're actually supposed to have 3 functions. It means this one is going to be the one that's going to be the inner, followed by your g of x. Then the outer one is going to be your f of x. You see? So we go with the same approach that, okay, I'm gonna write it down that, okay, my h of x, which is going to be the one in the internal. Okay, let me just like write it at the bottom. Is it possible? Okay, I have something like 1 over my ln of 1. Ln of 1 minus 2x. Minus 2x. Then they require us to find f of x. F of x. Then we have g of x. G of x and h of x. See, so something like this would be like 3 to 5 marks. So you go same approach. It means now you're going to start with this one. This is going to be the one that's going to be internal. Then this one is somewhere in the middle. Then this one is going to be the one that's going to be your external. So you go again and say, okay, what do I have on the internal? You can see from this one that, okay, just underneath this you have this one that's internal, which is your 1 minus 2x. You go and say you have your 1 minus 2x this side. And as I said, remember, each and every time you take out a function, you replace it with an x, and you also go and write what kind of a function do you have that side. This side I have my linear function. It means now I'm done with that one. So now I can say this now will look like 1 over my ln of x. See? So now I'm in the middle. What am I left with? It means now I'm going to be having my ln of x this side. Then you're going to consider the last one. It means from this one, this is going to change and be what? Remember, now I've pulled another function, my ln of x. Then your ln of x, this is which functions? This is your logarithmic. So logarithmic. So now I've only pulled my two functions. Now I've pulled this one, and remember, after pulling that one, you replace it with x. So it now means I'm going to be left with my 1 over x. Then here you just come and write your 1 over x. 1 over x can be written as your x to the exponent minus 1. Then these ones fall under which functions. These are going to be your power functions, and specifically these are going to be your cubic, because you can remember from the odd numbers that you're seeing this side, which is your -1 or your ones, because it's going to be your 1, 3, 5, 7. But in your head, when you know that, okay, I'm dealing with my cubics graph, because it's just going to be your 1, 3, 5. It means now your x to the exponent 3, this would be my parent function. So hence this side you're going to say you have your power function. So you see in one example, how many functions were you able to determine? You're able to determine that you had your power function, you had your logarithmic, and you had your linear, just by following those steps that like I've mentioned. And as I said, if you see that you are having a power and a power, quickly check if you are not doing anything wrong. There should always be something that's looking like this. You see, now I've extracted all the functions from this thing, and if I want to write them back, I can, because if I have to write something like my g of h of x, it means now I have my h of x inside of my g of x. And what's my g of x? My g of x is my external one, which is my ln of x. But you remember the rule, where I see my x, I go and input my h of x. Then I'll see I have my ln of, then you have 1 minus 2x. Then now what do I have? I can quickly go again and say, please write for me my f of my f of g of h of x. So now it means you're going to be having at this equation, you're going to be going back to that one. You see, so even if you're doing it like this way, it should always be able to take you back to the original one. So that's another way that you would know, okay, I'm still on the right track. Then okay, those ones are the ones where you have to do your domains. Let me just grab these. Okay, yeah. Just to check, does anyone have any question regarding the examples that like we did up until example 4? We are all on the same page. So yeah, so it seems like they are going to at least have like 4 ways they could ask you to do the example. So yeah, judging by no response, I'll just assume that like everyone is sorted with this type of questions. So now we're going to be going to example 5. So example 5, they're saying something like, okay, this is one is about finding the domain of a function. They say find the domain of the function and write your answer in set notation. Remember, your set notation is the one that you have your Cayley lines, then your intervals is the one where you can have your bracket or your closed ones, and so on and so on. So now you already know the type of bracket that you have to look with. So with the domains, basically the main idea about the domains, you have to check your what we call the restrictions. What are your restrictions? For example, if I have something like my 1 over x, what would be my restriction for this one? My restriction or first restriction would be that my x should not be equals to 0, because now I'm going to be getting something that's going to be undefined. So same thing, if perhaps I have something like, okay, you have your ln of x, then now you know that, okay, this one, or your solution, your x should be greater than 0, or you're going to get something that's undefined. What other one? So okay, let me just like write them down in this way properly. So let's just say we'll call them the domains of composite function. We have the domains of composite functions. So we said, okay, let's just say we have an instance where, let's just say we have our y is equals to 1 over f of x, like the example that like I've given. My only restriction, if we're having something like this, your x should not be equals to 0, or your whole thing is going to be undefined. So using the set notation, you're going to be having your x such that your f of x should not be equals to 0. So that would be the first one. Then the second one, you have you would have something like your square root of f of x. Remember, your f of x can just like represent any number. So now you're going to have your set interval as your x is such that like your f of x should be greater than or equals to 0, or you're going to get whatever that you have this side is going to be undefined. See? So the third one, it was the one that I was mentioning when you have your ln of f of x. So with this one, you're going to have x such that your f of x should be greater than 0. Hence, if you have your something like your ln of 0, you're going to be getting undefined on your calculator. Same thing. Yeah, I think I wanted the example that I wanted to give, we've already highlighted. Then okay, let's just say we have an example. What's the last example that I can give? Let me just check from these ones. Do we have a number this side? Okay, it's 3 square root of b squared. Okay, let's just also highlight something about that. Okay, if if I have something like your y is equals to your cube root of f of x. For this one, you can just like say x is your element of all real number line. You don't have any restriction for this one. So all the answers or all the values that you can use, they would definitely give you an answer. So the mainly thing about your restriction, you just like looking at a region where if you were supposed to use a certain value or number, you get your something like your undefined. Like in this example, the first one where I've given this is say you have 1 over x, then you say your x it's a 0, so you definitely know you're going to be getting something that's undefined. Same thing with this one. You know, if you have something like your square root of 0, you're going to get something that's undefined. But if it's a number that is greater than a 0, you're actually going to get something, a number, positive, whatever. Then same thing with this one. If you have ln of 0, you're going to get an answer that's undefined. But if you have something like your ln of 1 and so on and so on, you're actually going to start getting those numbers. Then for the last one, it doesn't matter, you can use your minus infinity to positive infinity. You're going to get answers for each and every value of those. So now we're just going to use this on these ones that like we've got this. So the first one, you can see we have 1 over something. We have 1 over t squared minus 81. So what would be our restriction? Our first restriction that comes in our mind is definitely gonna be the first one that we have this side, that like whatever we do, we should not let the bottom part of our equation be equals to 0, because once we have 1 over 0, it means now we're going to be getting something that's undefined. So what do we have? We have 1 over t squared we have 1 over t squared minus 81. So as I said, you know the bottom part could not is not supposed to be equals to 0, or you're going to get something that's undefined. Hence your t squared minus 81 should not be equals to 0. So that's that. Then we have to look for the factors of 81, that's 9 and 9. And we know that, okay, we're going to have minus 81, it means minus 9 and plus 9. You have t minus 9, then we have t Rahman. Then we have t plus 9, and as we said, this should not be equals to 0. Then remember the question said to us that like we have to find it the domain of the function and write your answer in your set notation. Set, remember, that's these curly lines that like you're seeing. So it now means if we were to represent this using the set, we can just start with it at the top that we have our t such that our t squared minus our 81 should not be equals to 0. Then we go to the second step that we have our t is such that we can just show the one for the factors. We have t minus 9, then we have the t plus the 9. Then the last one will just let's say we have your t such that your t should not be equals to your plus or minus 9. Because remember, these ones you're just going to be solving them separately. If I have this, your t minus 9 and your t plus 9, this I'm just like also solving it as if like I have 0. You know, this side you're going to be have your t is equals to 9. Then this side you're going to have your t is equals to minus 9. Hence, I just like included it in this final state. So yeah, so that would be your final answer in your set. So yeah, the mainly thing that like they're going to be interested in is to check your restriction, that like are you aware of your restriction that your whatever that you are having in the bottom should not be equals to 0, you see. Then the other mark they're just gonna give you for the factors and this, then that's how you're going to get your mark. Then let's just go and check another example. Another example, it's when what do you have? What's it? Is it a 4 or a 3 squared? It's got minus. Okay, I don't think it has a number. The one that has a number is that one on the other side. Okay, so add a page. Now we have the second one where they said I even forgot the question. What did they say? They have f of a. So now we're dealing with a's. So yeah, also you have to note each and every time they're using different letters in this thing. Here we were dealing with t's, here we were dealing with a's, here we were dealing with b's, here it's x, z, and your x. So when you are doing these ones, do not go and use your x instead of your t's. Sometimes they also penalize such stuff. Like I'm not sure if they're still that strict, but like pay attention to the letters that you are using. So we have this. Okay, now I think I have memorized it. Then we're going to it's been a long day. We have f of a. We have your a squared minus your a minus your 6. This is your square root. Then okay, we check what is the restriction for this one. We know the restriction for this one. If we're going to consider this and the square root, our x value should be greater than or equals to 0. So mainly you can say the restriction that like we have would be that okay, for this one, if we have our f of x, we must have this as greater than or equals to 0. So now we're gonna continue and say okay, they've requested us to write this question in a certain table. So we're gonna say first step we have a such that your a squared minus your a minus your 6, curly bracket. Then you go and check, okay, what would be the factors of minus 6, that okay, when you combine them they give you minus 1. Then you say a such that you have this to this side. Okay, I forgot the signs, sorry about that. As we said, this one we're going to be using a greater than or equals to 0. That will be the restriction that we have this side. As you can see, also this side we had the restriction. Then okay, we said we're going to be having a, then your minus 6, it's definitely between 3 and 2. Then between 3 and 2, which one is going to be negative? Or 3 is going to be negative, because minus 3 plus 2 is just gonna give you minus 3 by minus 2 is just gonna give you minus 6. Then minus 3 plus minus 2, it gives us minus 1. Then this side you have a minus 3. Then this side you have your plus 2. Then we still have the greater than or equals to 0. Then you do your curly lines. Then you will say your a it's such that your a it's less than minus 2, or your x is greater than or equals to 3. I just hope this one shows. As I said, we have your x is greater than or equals to 3. Then that would be the set notation for that one. Okay, we've done 2. Then the third one, what do we have? Do we still have something similar? We have a squared. I think this one, is it that a 3? Okay, let me just check in the book if that's a 3. Where's that book? Okay, yeah, that's definitely a 3. Then the other ones, they show imperfectly. What was I looking for? Okay, sorry about that. Okay, this one they're saying it's like this. They're saying it looks like this. You have your b squared minus b. I thought it's something that looks the same. Okay, let me just write it like this. Also here that you have your f of b is equals to your b squared minus b minus your 6. Then you have this. Then with this one, I think we've also included the restriction for that one. It's just going to be this, which is your x is your L element of all real number lines. basically meaning we don't have restriction for this one. You can input your values from minus infinity to positive infinity, and you're still going to get an answer. You're not going to get anything that's undefined, but we still have to write this in set notation. So how is it going to look like? Remember, now we're dealing with your b's. I'm going to say your b such that your b squared minus b minus 6 it's an element of all real number line. So yeah, just like that. You don't have to do any other necessary calculations or steps. Then the other one, let's just check. What do you have? Okay, you have f of x is your ln of it's your x cubed plus x squared minus 2x. Let me just check from the book. The ln of x, okay. They're saying you have your f of x is equals to your ln of x cubed plus your x squared minus your 2x. So you're having something like this, and remember, this should be coming from your ln, and you know, with your ln, the only restriction that you are having is that like your ln of x should always be greater than 0, or else you're going to be getting an answer that's undefined. So means now we're going to be using these restrictions that you see this side. So now it means whatever ln that you have of this thing, it should be greater than 0. So in short, it now means you have, remember now we're dealing with your x. I'm gonna say you have x is just that your x cubed plus your x squared minus your 2x should be equals to, no, should be greater than 0. As they've said, they are all in set notation. So now you go and check that, okay, for this one, let me just like write it here so that you can see I have, and this thing is off, I have my x cubed plus your x squared minus your 2x. See? So we have to break this one down that, okay, if we were to factor this, you can definitely see that, okay, we can factor the x out, that we can have the x into your x squared plus your x minus 2. And can we simplify this further? Yeah, we can. You're going to have your x into your 2 of this. Okay, you have your minus 2, you're going to have your minus plus 2 and 1. You have x plus 2, you have x minus 1. Remember, all of this is still greater than 0. But even if like you're just like testing this side and just like saying you're writing your equal sign, it doesn't matter, as long as like when you go to the other side you write your correct answers, then that's all that matters. So from this one, let's just pretend if now we're just like equating to 0. It means now we're going to be having our x is equals to 0, or our x would be equals to minus 2, or our x would be equals to 1. So I'm not sure, are we gonna include all the steps this side? Okay, I'll just like include this one that I'm seeing here. We can say we have x is just that we have our x into x plus 2 into our x minus 1, this is greater than 0. So I've only included this one this side. Then from now I already got the final answers this side. Then you can just like write your one for the final answer. So this side you can see we're going to be having from minus 2 to 0. Then that side we have x being greater than 1. So we have minus 2 to 0. Then this side we have x being greater than 1. So now means we're just going to be writing this one this side. That okay, we're going to be having this, or you can say all x is greater than 1. So yeah, these ones I just grouped them together. Even if you want, you can do them separately, and it doesn't matter. Then we're done with the lean one. Let me check if we still have more examples. Okay, we have two more. We have 2 more. I don't want to go far. Let me just erase these ones. This one. Okay, what do we have? We have f of z. F of z is equals to square root of z plus square root of 10 minus 10 minus z. Then after that, okay, we're only left with the one for lean. So this one I'm just gonna do it quickly because like we've already done the lean this side. So the only one that like I'm interested in is the one where you have something like your z. I'm so tired. Okay, I was seeing a space this side. We said we have f of z, which they give you a square root of z plus your 10 minus your z. So with this one, if you see a plus sign or a negative sign in between, just take them as 2. You will just like separate them by the end sign, but like the steps that you're going to be using, you're going to be using the same steps that like we used in the other examples. Like okay, so now you know that like if we have something like a root of f of x, this should be greater than or equals to 0, because like if you say this 1, you take your square root of 0, you know that you're going to be getting an answer that's undefined. Hence, you know your f of x or whatever value that you're going to be having, it has to be greater than 0. So now without okay, the stylus is almost out. Where's my other stylus? Okay, I'll try to use this other one and touch the other one in the meantime. So now you know, okay, we're dealing with what now? We're dealing with the z's. So you have to also pay attention for those. That okay, we have our Kelly lines, since we're still doing the z values, that our z is such that our z should be greater than or equals to 0. So now I'm only focusing on which side? This one. Then we'll say and is just to consider the other portion. sorry about that. Let me see, and this side we have the 10 minus z being greater than or equals to 0. So yeah, I'm just like using two different pens just to show the colors, just to show the difference that okay, we've started with the one on the left, then now we're doing the one on the right. And if you look at this one, this side, you have, let me just write it to the bottom, you have your 10 minus z is greater than or equals to 0. So let's pretend now we were having something that's like this. You're going to have your minus z is greater than or equals to 10. So now you know when you're having something like this and you're supposed to divide by a -1 just to ensure that our z is positive, we're going to divide by -1, then when we divide by a -1, the sign is going to be changing. Remember, this side we have this, so it means now we're going to say we have our z as less than or equals to 10. So remember, if we divide by a negative sign, this inequality sign changes. If it was greater than or equals to, it's gonna change to this one. If it was this one less than or equals to, it's gonna change to greater than or equals to. So those are the rules for that one. So now okay, we can go back to this one at the top that we've already seen that okay, this one is going to be your z is less than 10, as like I've explained at the bottom. So it now means your final answer is going to be having something like your z is such that your z is greater than or equals to 0, and for the other part your z is less than or equals to your 10. So that's how you do the one where you have an addition sign, or if it was something like a subtraction. If it was a subtraction sign, you still consider them, but like you do those ones separately. The only difference is that like you're just going to be using the end at the in between just to show that okay, now you're moving to the other function. So we're done with that one. Then this one, yeah, I'll just like do it quickly, then we can move to the other examples. Do it quickly. So today we should ensure that like we're done with unit 1. So what do we have? We have f of x is equals to your ln of 4 minus your x squared. You see? So with your ln, you remember what's the restriction for ln? You know, with your ln you can be having your ln of being equal to 0. So with your ln of x, this should always be greater than 0. So that's the restriction that you're going to be using. So it now means you're going to be having what? Remember, we're working with the x values, then we're still using the set intervals. Then we'll say you have your x is such that you have your 4 minus your x squared being greater than 0. Then you will know that okay, you have your x is such that you're gonna have your two brackets, then still have your greater than 0. Then you know you're going to have Okay, we have a positive 2, so it means you have 2, 2, and a negative and a positive. So you're going to be having that. I'm not sure if you're supposed to simplify it. Then if you're supposed to simplify it, you can write it in the simplified manner. But like, I don't see it wrong if you left it like it was at the top. Then that would be that for that one. Then let's just check another examples you're going to be getting. The other examples that you're going to be getting, it's where you're going to be getting a linear functions, and you'll see they like this type of format in your WTW, where they've given you something like your 2010, 2020, and so on and so on. So the mainly thing that you have to keep note is that, like, each and every time we're having something that looks like this, so you go and check, okay, if it's your years like this one that you see this side, you have your 2005, here you have your 2010. You only consider the last 2 digits. That, okay, here we're only going to be considering 05, this side we're going to be considering 10. So in an instance where they say estimate the population in 20, you're only going to be inputting your 20 in your function that you're going to get. And another thing that, like, I've seen that people get it wrong, it's okay, now you are given an example that's like this. Okay, let's just like read it together. You get an example that's like this, and they say, okay, in 2005 the population of a city was 3.49 million, and in 2010 the population was 3.74 million. Then find the formula for the population P in millions as a function of time, T in years since 2000. So that 2000, this is your T0. This would be your reference. See? This would be your reference. Then what else? Then saying, assuming that is a linear function. What's a linear function? Your linear function, you know, you have your y is equals to your mx plus b. You see, your m, you know, this is your slope that you're going to be having. Hence you can also see here they've also just like tried to show you m, that okay, you have your m, this would be equal to your delta y over your delta x. But like, one thing people just like forget is to know which one comes at the top and which one comes at the bottom. So looking at our example, what do we have this side? They've given us population and time. They've given us population in millions, and also they've given you time. So you have 2 things. You have population and time. Remember, as like they've taught us in high school, you have your Cartesian plane that looks like this. You have your y values, then you have your x values. So now what you have to do is to try and go and allocate your p and your y. And your y, you will see your p will come this side, and your time will come this side. And one thing that like I also have to say is that, okay, each and every time you're going to consider your x-axis, on your x-axis you're going to consider these ones that like are independent. You see, because time does not depend on population, but population depends on your time. Hence I'm putting my population on my y, because this one is going to be my dependent. dependent. See, so from the formula that you can see now that like we have my m is equals to your delta y and your delta x. So now you see you won't make a mistake of having to swap them around. You'll also put the correct one at the top, that okay, you're always having dependent over independent. See? So that would be that. Then now the other thing that's left is for you to point out the points that you're going to be having, because like in order for us to be able to calculate the slope or the m as indicated this side, you actually see that like we are supposed to be having 2 points that will help us to calculate that, because like from those points we're going to be having our y2, the other one is going to be our y1, x2 and x1. But in this instance, how are we going to put it in our case? We're going to say this one would be the t1, then this one is going to be the p1, then this one is going to be the t2, then this one is going to be the p2. You see? So let me just write them this side so that you see exactly what I'm talking about. Okay, in that order. Remember, in our point we're going to be having t1, then we're going to have a p1, then let's just call this 1.1, then point 2 we're going to be having the t2 and the point 2. So t1, as I said, remember you only have to take the 2 values that you see from this. This is your 2005, so you're going to take this last 205. Then on this other one, 2010, you're just going to take your 10. But one thing also that you have to note, check your populations. They said your population is in millions. You see, so you still have to go again and make sure that like you divide these values here by your million. I mean only your populations. You have this one this side, you have this one this side, and also this one this side. So considering those ones, it means now on our point 1, what are we going to be having? On our point 1, we've agreed that we're going to be having that 05 from 2005. Then the other one is going to be the 3.49. How did I get my 3.49? I got my 3.49 because basically I just went this side and divided this thing by million, because they said the population is in million. Even here you do the same thing, you get your population in millions. So if you do that, this side point 2, remember what do we have? We have 2010 this side. We're just gonna be taking the 10 and the 3.74 on the other side. So it means now this side we have, sorry for that, we have the 10, then we have the 3.74. See, and as I said, what did I say? We have our m, then we have we're going to be having the dependent over independent. We have the dependent over independent. So you can definitely know that okay, the population is going to rely on time, hence time is going to be independent. So you can say you have your delta P over your delta T. And as I said, in a Cartesian plane, you're going to be having your P, you're going to be having your T on the other side. So it now means you're going to be having P2 minus your P1 over your T2 minus your T1. See? So yeah, we are moving, almost getting through to our M. So if you go P2, we have our 3.74. We have a 3.74 minus our 3.49 over your 10 minus your 0.5. Then yeah, can someone just like quickly calculate that for us and tell us the answer? Yeah, just tell us the answer for this one, then like we'll just calculate it. 3.74 minus 3.49 over 10 minus 5. What are we getting?
0.026.
0,
No, it's 0.05.
0.05. Okay, thanks for that. We have 0.05 now. So basically, okay, I think I'm even answering the same the question at the bottom. So they're saying, okay, we have to find the formula. But like I'll just like get to it. Basically, this is the slope at which your population is increasing, and you remember now your population is in millions. So if you want to know that, okay, for each and every year, what would be the rate at which the population is increasing? So basically, what you're going to do, you're going to take your zero. Let me just change this. My stylus. Remember, this is in the form of your population. You're going to take your 0.05, then you multiply by that million. And this should give you something like your 50. Let me see. Yeah, your 50,000. So it means now your population increases at a constant rate of 50,000 per year. Then let's just continue with the question. Let's just continue with the question. Oh, we are not done yet. We've only found our M. Here I was just showing that, okay, it's increasing like this. So now we've only found our M. It means now our current function, we now have P is equal to your 0.05 T plus the B. So now we're only interested in finding the B. And in order to find our B, you can use any of the points that you like. You can use 0.1, you can use 0.2. You're gonna get the same answer. So I'm just gonna use 0.1 where what did I have here? 0.5 and your 3.49. So remember, how are this viewed? You have your X, you have your X this side, you have your y. So this will always be written in your x and y format. So what are you going to have? You're going to be having your 3.49 is equals to your 0.05 into your 0.5 plus your b. Then you have your 3.49 is equals to your 0.05 multiplied by 5. Well, what's the answer for that? Your 0.05 by 5.
0.25.
0.25. Okay, it's your 0.25 plus your b. Therefore, you can say your b is equals to, you have your 3.49 minus your 0.25. Then your b, it's how much?
0.24.
Then you'll come and say we have our b which is equals to 3.24. So now we have to write our final function. I'll say we have p which is equal to the 0.05 t plus your 3.24. So this is going to be the final equation that they are interested in. So yeah, those are just the steps, and you will see most of the questions, they're like somehow in this like form. So whatever we've discussed this side, make sure that like you were able to understand, including your independence and your independent values. So now number 2, they say interpret the slope of the linear function. Remember what's the value that we've got? We've got your 0.05, and I guess I've said you just have to take this your 0.05 multiplied by that 1 million. So it now means the population increases at a constant rate of 50,000 people per year. See? Then you're done with that one where they say interpret. Then they say estimate population in 2020. So here you only have to consider the last two digits, which is your 20. Then you go to your function that okay, you have to find your population in your 2020. You have your 0.05 into your 20 plus your 3.24. Then what are you getting? Then you get your 4.24. And remember, these values were already divided. It means now you're getting 4.24 in millions. Because in section B and section C, you're actually supposed to do your conclusions. And each and every time you do your conclusions, make sure that like you're stating your things correctly. So here you'll just go and say the population in 2020, something like the population is 4.24 million. So yeah, well, that's it. Then you go and check that okay, we've done the one for that one. Then now the other type of question they would ask, that's one in example 2, where they say if the function below represents a linear function, find the formula of the function. You see, you remember the format where I told you that okay, you have your delta, you have to consider this this gradient that you have. So if you look at this, you can go and use any of the value that you have. So let's just assume we were about to take this a table. You can just say the 20 it's your x1 and your 40 it's your x2. Then all your y values you do the same thing. Okay, your 90.5 is going to be your y1, then this one is going. Okay, let me just write it down also so that you get what I'm trying to say. So basically it's like you're plotting this into points, but actually just taking them from the table. Remember, in order to have a point you need to have your x and y values, you see. So let's just say the first ones that you're going to be having on this one, okay, let's just say it's 0.1, this one is 0.2. The ones that you're going to be having this one, okay, we can just take these ones together. Let's do this. We can just take this one, x and y together, then we also take these ones together. That okay, on your 0.1, what do we have as your x? You have your 20, your y, you have your 90.5. Then on this side, what's your x? You have your 40. Then on that side, you have your 89.8. Then you know that if you were to find your gradient, which is your m, you're going to be having your delta y over your delta x. What are you going to have? This one is your y2 by 1. You have your y2 minus your y1 over your x2 minus your x1. Then what do you have? There's someone whose mic is on. Can you please switch it off? You have your 89.8. 89.8 minus your 90.5. Then your x. Can you please switch off your mic? I don't know where it is. Guys, there's someone whose mic is on. Can you please switch it off? You'll just switch it on when you have something to say. Then we said y2 minus y, we have 89.8, then that side is 90.5. Then here we're going to be having your 40, then that side minus your 20. And yeah, can you please calculate that for us?
negative 0.45, negative 0.045,
negative 0.045,
0.45.
0.45. Yeah, but then remember I only used this to this side. So indeed, if like you want to confirm that this it represents a linear, you can go and use your 60 and 40 and see if you're still getting the same gradient, because like if it's a linear you still have to get the same gradient. So this is one of those questions where they also like to ask it in the MCQ. I actually remember like writing this one in the exam. It was like asked in a different way, but like I remember it was there. Oh yeah, they were actually even asking about the gradient. So you do the same thing with the other table that you see there. This one, this side, you just follow the same step that like we did. Then you get the answer. For now, let me just check in the book what we did. Okay, yeah, we're only left with the other 3 questions and the other ones where you have to know how to draw your your first derivative graph from the original function that you're going to get. Check what else. Then from then it's just and that's unit 2. And then I feel like eating. So what are you guys saying? Should we continue around 8:30? But like don't worry about the extra means, because like so far we've done 2 hour 18 minutes, but like I'm just willing to add the extra 30 minutes on my side, because like we had taken some of your time. Then when we come back we'll just like quickly finish those other examples. So for today we'll just like take it as 2 hours as it is. Then we'll come back around 8:30 to do the remaining ones, then be done with theme 1. The other themes I just feel like we're just going to be running through them, as long as like we can understand this one specifically where it has to do with the what's this thing, the graphs. Then going forth it's just gonna be easy. For today I will just say after this lesson you can just like go and just like maybe redo some of the questions, then try to do what's this thing, examples on your derivatives, which is your theme 2, so that like even when we're going to do it tomorrow it doesn't get too confusing for you. So I think we'll just like use the same link when we come back. So now I just wanna at least maybe get some meal, then after eating we'll just come back and do the remaining examples and see if we have anything to add. So bye for now, see you at 8:30. Let me stop this session. 2 hours 20.